First question is, if alpha and beta are roots of ax square plus bx plus c equal to 0, find the values of the following expressions. First is alpha square plus beta square. From the quadratic equation ax square plus bx plus c equal to 0, we know that sum of roots alpha plus beta will be equal to minus b by a, and product of roots alpha into beta will be equal to c by a. So we can write that alpha square plus beta square equal to alpha plus beta whole square minus 2 alpha beta, and now substituting the value, we will have minus b by a whole square minus 2 into, and alpha beta is c by a. So this will be equal to b square by a square minus 2c by a, and we can write it is b square minus 2ac by a square. Part B is 1 by alpha square plus 1 by beta square. It can be written as taking the LCM, that is alpha square beta square, and numerator will have the value beta square plus alpha square. Further, we can write that alpha square beta square is the square of the product of roots, so it is c by a whole square. In part A, we have calculated alpha square plus beta square, the value is b square minus 2ac by a square. So we can find that b square minus 2ac by a square into a square by c square, a square get cancelled, hence value is b square minus 2ac by c square. Part C is alpha by beta plus beta by alpha. It can be written as beta into alpha by taking the LCM, and numerator have the value alpha square plus beta square. From part A, we can replace the value of alpha square plus beta square. This is b square minus 2ac by a square, and it is denominated by the alpha beta, which is the product of root, and it is c by a. That is equal to beta square minus 2ac by a square multiplied by a by c. One a get cancelled, so value will be b square minus 2ac by ac. And part D is alpha cube plus beta cube. We can write it is alpha plus beta by taking the factors, and other factor is alpha square plus beta square minus alpha beta. It can be further written as alpha plus beta into this alpha square plus beta square can be written as alpha plus beta whole square, and then minus 2 alpha beta, and rest is minus alpha beta. So we can write it as alpha plus beta into alpha plus beta whole square minus 3 alpha beta. Now we can replace alpha plus beta by minus b by a, this is the sum of roots, and alpha beta by c by a, this is the product of roots. So value will be alpha plus beta is minus b by a, then alpha plus beta square, that is minus b by a whole square, minus 3 into, and alpha beta is c by a. Now simplifying it, it is minus b by a, it is b square by a square minus 3c by a. It is written as minus b by a. Taking LCM, it is a square, and numerator will have value b square minus 3ac. So we can write it is a cube in denominator, and numerator have the value minus b cube plus 3abc. So we can finally write it as 3abc minus b cube by a cube. Second question is, if alpha and beta are roots of ax square plus bx plus c equal to 0, then find equation whose roots are. Part A is alpha plus 1 by beta and beta plus 1 by alpha. Given quadratic equation is ax square plus bx plus c equal to 0, and roots are alpha beta. So we know that sum of root alpha plus beta will be equal to minus b by a, and product of roots alpha beta will be equal to c by a. For the given roots, sum is alpha plus 1 by beta plus beta plus 1 by alpha, which can be written as alpha plus beta plus 1 by alpha plus 1 by beta, that is equal to alpha plus beta plus, taking the LCM alpha beta, it is alpha plus beta. Now substituting the value of alpha plus beta and alpha beta, we will have minus b by a plus minus b by a divided by c by a. This a and a get cancelled, so it is minus b by a and then minus b by c, or we can write it is minus b 1 by a plus 1 by c, and finally minus b into a plus c by ac. Similarly, product of roots will be alpha plus 1 by beta into beta plus 1 by alpha. Opening the bracket, we will have alpha beta plus 1 plus 1 plus 1 by alpha beta. So it is alpha beta plus 1 by alpha beta plus 2. Replacing the value of alpha beta, this is c by a plus 1 by c by a plus 2, that is equal to c by a plus a by c plus 2. Taking the LCM, it is AC, and numerator will have value c square plus a square plus 2ac, which can be written as a plus c whole square by ac. So equation which have the sum s and product p will be x square minus sx plus p equal to 0, as discussed earlier. Replacing the value of s and p, we will have x square minus sum is minus b a plus c by ac, and then product is a plus c whole square by ac, and it is equal to 0. Taking the LCM, it is AC, so we will have AC x square plus b into a plus c whole square divided by AC equal to 0, or we can write it is AC x square plus b into, this is x also here, b into a plus c into x plus a plus c whole square, it is equal to 0. This is the answer. In part B, we have to find the quadratic equation whose roots are 1 by a alpha plus b and 1 by a beta plus b. The given quadratic equation is ax square plus bx plus c equal to 0, and roots are alpha and beta. So first we substitute the value x equal to alpha. It will satisfy the equation. Therefore, a alpha square plus b alpha plus c equal to 0. Rearranging the terms, we will have alpha taken common. It will be a alpha plus b equal to minus c. Therefore, a alpha plus b will be equal to minus c by a alpha, and 1 by a alpha plus b equal to minus alpha by c. This is the one of the root. Because beta is also the root of the quadratic equation, so it will also satisfy, and we have another equation. This is 1 by a beta plus b, that is equal to minus beta by c. This is the equation number 2. So equation 1 and 2 represents the roots of the quadratic equation which we have to find. Therefore, sum of the roots will be equal to minus alpha by c plus minus beta by c. This will be equal to minus 1 by c alpha plus beta. And replacing the value of alpha plus beta, which is minus b by a, this will be equal to b by ac. Similarly, product of the roots will be minus alpha by c into minus beta by c, that will be equal to alpha beta by c square. Replacing the value of alpha beta, it will be c by a by c square. Therefore, we will have the product AC. Now, a quadratic equation will be equal to x square minus sx plus p equal to 0 in terms of their sum and the product of roots. Replacing the value of s and p, we will have x square minus sum of roots is b by ac into x plus, and product of root is 1 by ac equal to 0. So this will give ac x square minus bx plus 1 equal to 0. Third question is, if alpha is not equal to beta, but alpha square equal to 5 alpha minus 3, beta square equal to 5 beta minus 3, find the equation whose roots are alpha by beta and beta by alpha. Given expressions are alpha square equal to 5 alpha minus 3 and beta square equal to 5 beta minus 3. From observation, we can say that these alpha and beta will satisfy the equation x square equal to 5x minus 3. And this can be written as x square minus 5x plus 3 equal to 0. This is in standard form of the quadratic equation, which is ax square plus bx plus c equal to 0. On comparing, we will find that a equal to 1, b equal to minus 5, and c equal to 3. So because alpha and beta are roots of this quadratic equations, therefore sum of the roots alpha plus beta equal to minus b by a, which will be equal to minus of b is minus 5 and a is 1, that will be equal to 5. And product of the roots will be c by a, that is c is 3, a is 1, so it is 3. Now we have to find the quadratic equation whose roots are alpha by beta and beta by alpha. So sum of the roots alpha by beta and beta by alpha will be equal to, Taking the LCM, this is beta by beta alpha, and in numerator it will be alpha square plus beta square. It can be written as alpha plus beta whole square minus 2 alpha beta by alpha beta. Now replacing the values, we will have alpha plus beta is 5 square minus 2 into alpha beta is 3 divided by 3. So it is 25 minus 6 by 3, that is equal to 19 by 3. Similarly, product of the roots will be alpha by beta into beta by alpha, that will be equal to 1. Hence the desired quadratic equation will be equal to x square minus sx plus p equal to 0. Substituting the value of s and p, we will have x square minus 19 by 3x plus 1 equal to 0, or x square minus 19, this is 3x square minus 19x plus 3 equal to 0. This is the answer. Fourth question is, if alpha beta are roots of the equation x minus a into x minus b plus c equal to 0, find the roots of the equation x minus alpha into x minus beta equal to c. The given equation is x minus a into x minus b plus c equal to 0, and it has two roots that are x equal to alpha and beta. So we can write the equation in terms of its roots as x minus a into x minus b plus c equal to x minus alpha and x minus beta. Because alpha and beta are roots, so substituting the value of x equal to alpha or beta, the left hand side will become 0. We can arrange this expression as x minus a into x minus b equal to x minus alpha into x minus beta minus c, or x minus alpha x minus beta minus c will be equal to x minus a into x minus b. This expression will become 0 when x will be a or x equal to b. So we can say that roots of equation x minus alpha into x minus beta minus c equal to 0 will be x equal to a and x equal to b.